Hello, everybody. This is Mr. Bronze, and we are starting off our year with the first video. And hopefully by now you had read Chapter 2. And I don't know, maybe you're feeling good about it. Maybe you have a couple of questions. So what we're going to do today with this video, for those of you learning at home, we're going to take a look at the skeleton notes from Chapter 2. So for the people who are actually in person in class with me today, we'll be talking about these and filling them in as we go. So you're going to hear my voice, and we're going to fill this in as we go together, kind of get these ideas down for Chapter 2. So some of you may have checked out Chapter 1. I'll add a couple pages, 3 or 4 pages. Just real general sort of information thrown your way, kind of get you warmed up to the idea of statistics. But I feel comfortable when I say I don't think it was anything that you didn't already know. So let's talk about the beginning of Chapter 2 and talk about what is data, what do we do with data, how do we get data. And the first big idea that we talk about in Chapter 2 is using context, because data without context really has no meaning. Okay, so it would be as if I said to you, how far do you live from Rocky Point High School? And your response was 7. There's no context there. Did you mean 7 miles? Did you mean 7 minutes by car or any other kind of vehicle? Did you mean 7 blocks? So there's no context to that value. So what we're going to do here in our first part, and I'm going to bump this up, I think, to 16 for now. We're going to drop in a little text box. And as you can see, I'm using Kami. So hopefully everyone has Kami on their Chromebook, which you should. So we have context of data. So Kami gives us the ability to open up different documents, and mostly PDFs. And then that's really the way it's designed. So PDF documents, which I'm going to push out to you guys through our Google Classroom. So today, you would have clicked on the link and downloaded or gotten access to this PDF file. And then when it opens up at the top of the page, you click on the link to Kami and open it up that way. And then we have our ability to fill in our notes as we go. So why don't we also do this? Let's change our color to red. I like that. Okay. So how do we get context? That's the next question. We understand what context is. Okay. It's going to help us sort of understand what our data values are. So context really is sort of developed through answering a couple of questions. And we talk about these questions as the W's. Okay, so what are the W's? Well, that's kind of a little bit of a misnomer, because we actually have an H thrown in there as well. So our W's, and this might go back to your English class, consist of the who, the what, the why, the where, the when, and here's our non-W, although it ends in a W, the word how. Now, let me just be very forthcoming with you and telling you that we don't always have to answer all of these questions. I don't want you to think that every time we look at a data set or a singular piece of datum, remember data is plural, datum is singular, that we suddenly have to ask 6 different questions to get context. Often 2 to 3 really provide the context we need, so we can feel comfortable in doing that. So if we can answer some of these questions, that really puts the data and paints a picture for us with the data that allows us to then go and organize, analyze, draw conclusions, run tests, all the different techniques we're going to use this year throughout our curriculum. So let's focus on these W's for a minute. Taking a look right now, we are checking out what do we need to know for the minimum to be able to say anything useful about the data. All right, so we talk about these six different items, and let me move that over a little bit. There we go. And really, we want to start with the who, the what, and the why. If we have the who, the what, and the why, that's kind of like the minimum to be able to say or make useful statements regarding our data. Okay, without any of that, we really sort of run into a bit of an issue, and we can't move forward with that. I know I'm not talking, so I don't want anyone to get nervous. I'm looking for my Screencastify. All right, there we are. I just want to make sure we're still recording. Sorry about that, guys. It's been a while since I used Screencastify, and I forgot it kind of disappears on me. Just got a little nervous there. Okay, so let's get back to business. So as long as we have the who, the what, and the why, we've got a great jumping off point for our data. Now, we talk about cases. Data is often given to us as a list. We see it in tables. We see it in diagrams. We see it in graphs. Tables is really a good jumping off point for us because we can take a list of data or any kind of data set that we've collected, and we can organize it, into tables. So we use the term cases, and the cases are really the who. Okay, what are we talking about in our data set? Are we talking about particular people? Are we talking about groups of people? Are we talking about teams, whatever it might be? Who are they? Who are the cases? Next up, we want to talk about variables. That's where our what comes in. Okay, so our what kind of defines for us the variables that we have. Now, your variable is kind of a descriptor term. Okay, it gives you information about your cases, and that's important. We need details. Okay, and then finally, we got the why. Can't leave out the why. There he is. All right, so we've got the why last from our who, what, and why. And the why kind of quantifies the decisions that we're going to make about the variables. How are we going to treat them? What are we going to do with them? So certainly very important. All right, now, data tables. As you saw when you did your reading on page 8, gave you a couple of pictures of some data tables. I didn't reproduce them here because we're actually going to see a little bit further in our notes when we have a practice question. They're very useful in organizing data. Okay, so the key is reading it properly. So we've got rows and we've got columns in any table. If you've used any type of spreadsheet, you know you've got rows and columns, and often you're labeling those to sort of identify the values that you place within the cells in each table. So when we talk about just the rows themselves, the rows really correspond to different individual cases. Individual cases, there we go. So we've got a table and we've got a series of cases. Could be a few, could be a rather large table with many, many cases. But either way, each row will give you the data that corresponds to each case. Now, we want to sort of understand right off the bat, individuals do not always mean people when we talk about tables. They can, okay? Let's say that you are off in the Riverhead outlets and you're walking around, you're doing some shopping out with your family or friends, and someone is standing there with a clipboard in their hand and they say, hey, we'd like to ask you a few questions for our survey. Would you mind answering them? And you being the polite individual that you are, you say, sure, I would absolutely love to do that. You are now a respondent. You are responding to the questions in the survey. Respondent. So now the data that you provide along with all the other respondents for the survey, will then be used by whoever is conducting the survey to draw some conclusions. They're going to organize the data, they're going to analyze the data, and then most often they're going to make some sort of decision based upon that data. Okay, how about people on whom we experiment? Now, don't think that, we have anyone against their will. We're talking about volunteers, willing volunteers for an experiment. So they're often referred to as either subjects or participants. Currently, with the COVID vaccine being developed, several different companies are working on that. They have subjects or participants that are participating in those trials. And they're being experimented on. So they are subjects or participants. But then we have this last group here. What do we call animals, plants, or even inanimate objects that we may experiment on or have data that we draw from? Well, these are kind of given a very generic term. They're referred to as experimental units. So that's really our three groups. We either fall into respondents, subjects or participants, or experimental units. And what we talk about when we're gathering data, normally we don't have the ability to gather data from everyone, from an entire population. Because think about why we gather data. We want to find out information, or we want to make a decision about normally a large group of people. It's very cumbersome to try to get to every single person. Think about if we wanted to survey all the residents of just Rocky Point alone, and we wanted to know some information about them with regards to their property taxes and how much they pay a year. And maybe you're doing a project and you're researching school budgets and property taxes, just for a hypothetical. How easy do you think it would be to get in touch with every single homeowner who pays property taxes and get them to participate in your survey? It's very difficult. It's very time consuming. It costs money. You need manpower. That is why we use samples, because that is just a small example. Think about a population bigger than the town of Rocky Point. What if we wanted to know about the city of New York, or the state of New York, or the United States, or North America? We can continue to get larger and larger until the whole planet Earth. We can't possibly get everyone in the population. So we draw a sample. And if you notice here, and this is key, look at what we have. You may want to highlight this. I think I have a highlighter over here. Whoa. We don't want that. No, that's an eraser. Drawing. I'll take a look at it later. Hopefully representative is something I would say would be good to sort of circle or underline. When we say hopefully representative, we want a sample that is a snapshot of our population. Okay, so if we have a population that is, say, 50% male, 50% female, and you take a sample and it's only 10% male and 90% female, that's not representative of the population. So we got to think about those things as well. And when we get into later chapters in the book, we're going to talk about how extensive the preparation is for actually drawing a sample. Okay, so we kind of went off on a tangent there. Let's get back to business. So what's the difference? How do we define the difference between, say, a population and a sample? So a population really is an entire group. So we're going to start with an entire group of individuals or instances that we hope to learn. Hope to learn about. Left out the about. Bingo. All right, there we go. So there's our population. So when we're done, we want to have enough information, enough data that we have now learned something new about the population. So the sample is sort of our mechanism, taking a sample to get us to that sort of conclusion, those kinds of information that we want about our population. So a sample is a representative, and that's the key word here, a representative subset of the population. I hope this typing isn't too loud for you guys. Apologize if it is. And I need to spell correctly. There we go. And we're going to say not only is it a representative subset of the population, but that is, what do we do? It's examines in hope of learning something about the population. Okay, let me jump over here. And for those of you at home watching and listening to the video, obviously you've probably already taken advantage of the ability to pause. Sometimes I can type rather quickly, so I do apologize for that. All right, so now let's kind of talk about a little bit about these W's. We're going to start with the what today. So variables, we said earlier, are the what. Okay, now when we talk about the what, we're talking about characteristics. So we say, what about it do we want to know? We're going to say, what are some of the characteristics that we've recorded about each individual? What is the information that we've gathered? That's important. Okay, that's your what. And we got a little bullet here. We want to add a little bit more to this, kind of elaborate. And we're going to get specific a little bit. And the thing about variables, and variables is a common mathematical term. You've been using it for years. And the thing about variables is they need units. Goes back to what we said at the beginning. How far away do you live from Rocky Point High School? If you gave an answer of 7, that's somewhat inconclusive. We don't know. 7 what? So what we say about variables is that variables may have measurement units. Now, do all variables have measurement units? No, there are some cases that they won't, but that's very rare. For what we deal with in this course, we're pretty much going to have measurement units with our variables. And what do these measurement units provide us with? What kind of information? Units, they tell us how values have been measured. Okay. Ends provide scale. So if we are, say, talking about 2020 year model pickup trucks, and we're comparing, say, fuel efficiency. So we're talking about fuel efficiency, a variable in that case for fuel efficiency would be MPG, miles per gallon. So that's our units, right? Miles per gallon. And then that provides a scale from which we can grade, or we can measure these different trucks, these different variables against each other. And then we can come up with a conclusion which has the best fuel efficiency, which has the worst fuel efficiency, etc. So that's important. Okay, so let's get down here and talk about variables a little bit more, because they're really, we can really take our variables and drop them into 2 different groups. Okay, the first group we're going to talk about is categorical. Now, categorical data is a lot like it sounds, categories. Okay, so when we have a variable, so when a variable names categories and answers questions about how cases fall into, jump over here, how they fall into those categories. So If we talk about, get back to the 2020 model year pickup trucks, we may have different categorical variables, things such as, say, color, transmission, engine, that type of thing. And we can put them in different groups, and then it kind of answers the question about how it falls into a category. If a truck is red, okay, now we know it's the color that falls into that group. What do we do with these categories? Well, if you think about it, let's go off in a different direction with this example. Let's say the teacher parking lot. We're talking about vehicles in general. And we might just have one category in different group of colors, right? Red, black, green, blue, gray, etc. What do we do with that? Well, we take counts, right? We go through the parking lot and we count up how many red vehicles do we have? How many black? How many white? How many green? How many blue? And we record those values. So what we want to add here is often we think about the counts of cases that fall into each category. So kind of two things that work very well together when we're talking about categorical variables, how they're developed, what they are, what they do, and how we sort of think about them. Okay. Then there's quantitative. Quantitative with the root word of quantity. We think of counts, right? We think of, not counts. We think about some kind of units, some kind of unit of measurement. So are we talking about feet, miles, yards, if we're talking about length? So a quantitative variable, we say when a measured variable with units, and that's the key, you need units to go with it, answers questions about the quantity of what is measured. And we'll bring measured down here on the second line. Quantity of what is measured. Okay. So quantitative variables, when a measured variable with units answers questions about the quantity of what is measured. Okay. So hit you with a couple of different items so far today. Let's take a look at one of these tables that we were mentioning earlier. Okay. And our example here in our table shows data for the 8 longest roller coasters in the world as of 2015. Our data is a few years old, but that's okay. So look at these different variables. Look at the labels across the top. We've got length measured in feet. We've got type. We've got speed measured in miles per hour. We've got height measured in feet, drop measured in feet, and we have continent. So the question we want to answer is, which of these variables are categorical and which are quantitative? So why don't you pause the video and take, as long as you need, take a minute or 2 minutes and take a look at those 6 variables and write down underneath in that space which variables you consider categorical and which you consider quantitative. And then when you're done, unpause and come back. Okay, so you've gone through your different variables, and let's see which ones you've identified as categorical. So once again, remember, we said categorical variable is a variable when a variable names categories and answers questions about how cases fall into those categories. Often we think about the counts of cases that fall into each category. All right, so which of these do you think falls under that description? Well, one of the things I noticed right away, and I hope you did too, is that 4 out of the 6 variables have units of measure. Okay, length, speed, height, and drop. The other two, type and continent, do not. They are more descriptive in their terms. Okay, we see our type of roller coaster. We have steel and we have wood. We can take account. We've got 2, 4, 6 steel roller coasters and 2 wood. So type would definitely be categorical. If we talk about continent as well, we see we have 3 that are located in Asia, 1 in Europe, and 4 in North America. So let's scroll down, and we want to add to our categorical. Let's get in here. Our categorical variables were type and continent. Good. All right. Then what was our quantitative? So our quantitative, remember, when we defined it above our table, we said when a measured variable with units answers questions about the quantity of what is measured. So that's kind of a dead giveaway for the 4 different quantitative variables that we had that all had units of measure. So our quantitative consisted of the length of the roller coaster, the speed at which it traveled, the height of the roller coaster, as well as the drop. So there's our 2 different types of variables. Okay, so we're going to wrap things up here, and we're going to kind of summarize. Well, I shouldn't say summarize. We're going to add to some 3 different concluding points here that I want you guys to really walk away with. First off, when you're looking at variables, before you go ahead and put it in one of the 2 different boxes of categorical or quantitative, you want to think about the question that you want it to answer. Okay, that's an important thing. What are you doing with these variables and this information that you've gathered? So let's add for our first bullet that we don't label a variable as categorical or quantitative without, and that's the key word here, without thinking about the question you want it to answer. Let's see if we fit at the end to answer. Perfect. All right, so that was our first point. Our second point, and this is something that's a very easy trap to fall into. This is why I like to sort of leave you with these points at the end. If you have a variable that consists of numbers, don't assume it's quantitative. It could be categorical. Okay? It's not always quantitative because it's a number. So we're going to say, just because your variable, or say your variable's values are numbers, don't assume that it is quantitative. And a good example of that would be a ranking, right? If we had a ranking associated, let's say the top 10 movies of 2019, they would be associated with a number from 1 through 10. But those aren't quantitative numbers, okay? They're categorical. They're a ranking. So, and last but not least, this is kind of a catch-all, and I will probably repeat this many times throughout the year when it comes to data and it comes to statistics that you're analyzing. Always be skeptical, okay? You want to investigate, you want to research, you want to gather information, and double and triple check, and then do it all over again. Always be skeptical of information that's thrown your way. Open up a newspaper, open up a magazine, get on the web. Numbers are everywhere. Okay, statistics are everywhere. Can't get away from them. Right now, we've got statistics thrown at us with regards to the COVID-19. We've got statistics thrown at us for the upcoming presidential election. We've got statistics thrown at us based upon any of the news items that you see, sports, weather. Always be skeptical of statistics. Investigate, investigate. All right, so I'm going to leave you with that. You have now gotten through our Chapter 2 notes, which is great. I hope this video was helpful for those of you at home today. I will see you back in school on Monday. Looking forward to that. I will be posting an assignment for you to work on, a couple of questions to think about and complete and then submit to me. And that will be in the stream as well, and the assignments. So if you have any questions, as always, please contact me, reach out via email on the Google Classroom, and let me know what's going on. All right. Thanks for joining me today, guys, and I'll see you soon. Have a great weekend.